practice that you expect to be confused and screwed on the test. And what would really be good is if you practiced it, and if you ran into any difficulties, you were able to show me on Friday, and I could help you figure it out, because on Monday it might be too late. All right, so moving on, what we then would have is the same thing going on, but with lenses. I'm not going to redraw all of them. I'm just going to briefly talk about what's the difference with lenses. What's that? They're the same thing, actually. All right, so I'm going to start with a convex lens. All right, how many focal points does a lens have? Why? Light goes from both sides. So if light comes here, there's a focal point. If light comes here, there's a focal point. Here's the good news, which we don't prove, but it's easy to prove using a bit of calculus and math. The focal point's exactly the same on both sides. You can never design a lens that has different focal points going one way than the other way. So if this is 15, this is 15. You can never get different focal points. The two focal points are exactly the same distance from the lens always. All right? So what we do is, let's mark them as such. So I've got two focal points, and I'll put my object outside the focal point. All right? And the same rules apply as what we had for mirrors, except that light goes through instead of reflects. But honestly, guys, it's the same approach. What kind of a lens is it called? Diverging or converging? Converging. So make sure that the line you draw on the other side converges, meaning moves towards the axis. So in comes horizontal. Now, what does it do? It converges, so it aims for the focal point. Everybody see that? Right? Okay. It comes in horizontal and aims for the focal point. Why doesn't this focal point have anything to do with it? Because it's not, I mean, once it's got to the mirror, this one's out of the question. But we do use this one for the second ray, which is if a ray were to go through this focal point, what would it do on the other side? It would come out horizontal. Why? Because if a ray came in horizontal this way, where would it go? To the focal point. The way to test is, can you reverse it and make it still work? If a ray comes in horizontal on this side, it'll get bent towards the focal point. Hence, if it comes from the focal point, it'll get bent horizontal. All right? And then the good news with lens is that this is the easy one. The ray that goes through the center of the lens doesn't change. So it's just a straight line to the center. That's always true for every kind of lens, converging or diverging. The ray that goes through the center of the lens just straight through. And now we've got ourselves an image. What kind of an image is this? Why? Because it's where light really went after hitting the lens. The light came to the lens and kept going, and that's where my image formed. That makes a real image. Yeah.
And in this scenario, since we're using the right-hand side focal length, it's positive. Yes.
The reason the focal lengths are positive, yes, is because light really goes to both of them. Yeah.
So do we place the focal points ourselves on the line?
I either will give them to you or you'll be calculating. Yes, you'll have the information to place the focal points. Because if I don't tell you the focal points, then I have to give you both S and S prime. And mathematically, that's an interesting question, but that's never what happens in real life. We choose a lens that has a focal point, and we get an image from it. So I will always give focal points because you're going to go to the store, buy this lens, you're going to know the focal point. All right. If I do anything else, it's just a math game instead of a physics question. It's not that there's anything wrong with math. I like math. But I want to make this more physics. All right. So, everybody good with this? So, yes, I'm changing my tune. All right, so let's do the same thing now for converging. We're going to do a converging lens set. Yes?
So, okay, so this one is a real image.
Yes, because
The light went through.
the light actually goes there.
It was on this side that it was.
If it formed an image on this side, which, hang on, we're going to do just that.
And then you're going to turn it.
Well, if you listen, you'll hear it explain as we go. All right, so here's the deal. We're going to draw our same three rays. What's the first ray I'm going to draw? Based on what you've seen me do so far. You don't have to do this order, but I pick an order, and if I teach you that order, then hopefully that'll give you some confidence to start. Draw it in parallel. Hit the straight line, not the lens, hit the straight line, and then do what? It's going to head to the focal point. Right? Right? So we come in parallel, we go through the focal point. That's what they do. Now, what happens? Focal point on this side, I can't aim to it, but I can come from it, just like we did with the, so I imagine that light's coming from that focal point, and when I hit this here, what's it going to do? If it comes from the focal point, it's going to come out. It's a lens, it's going to come out this side, but what shape?
Horizontal.
It's going to be horizontal, it's going to come parallel to the axis. Right? Think, just play that reverse. If it comes in parallel, it's going to go through the focal point. So if it comes from the focal point, it's going to come out parallel. Talk to me. All right. All right. So here's the thing. This is a converging lens. Are these rays converging? Yeah, actually they are. Look at them. This one's coming. So what it looks like is if I were to extend them backwards, they would converge kind of thing. But so, here, what I mean by converging, look at this. If I didn't bend it, it got converged by getting bent to here. So it would have gone here, but it got bent to here. So I mean, they're diverging, but it's more converged than it would have been. So all I want to do is converge just means to bring it together. It doesn't mean that it actually has to converge. It just, if it bends towards the axis. All right, and then what's the last ray? Center. All right. And so at this point what we do is we say this looks like it came from here. This looks like it came from here. And this looks like it came from here. And it's upright, therefore virtual. Right? Even though I've got a converging lens, it did make a virtual image. And in this case we see that the image is larger than the object. Any time an image is larger than the object, you have a converging lens or mirror. Diverging lenses and mirrors can only make smaller images. That's what we proved just a second ago from the math. Diverging lenses or mirrors can only make images that are smaller than the objects. If you ever have magnification, you've got a converging lens. So, you all know what a magnifying glass is, right?
Yes.
What's the point of a magnifying glass? To old people who want to read things, or young people who want to burn holes in paper, or, so it's called a magnifying glass because it's making an image that's bigger than what we started with. Is it a converging or a diverging lens? It has to be converging because diverging cannot make images larger. It's always smaller. So if we got it bigger, it is definitely converging. Is it real or virtual? Oh, the magnifying glass makes a real or virtual image. A magnifying glass that you're using to magnify something is real or virtual. Okay, that's exactly right. It's upright. It has to be virtual. If you get it to where it's upside down, you're using it for something else. So if I'm using it as a magnifying glass, we've got to make virtual images so it doesn't flip upside down. All right. So I guess we're going to get done with number one today. That's cool. You'll have a chance to be ready to hear the answers to questions on the other one. And this is worth a bunch of points, so it's worth doing. All right. So now we're going to do a concave or diverging lens. All right. And this is a little strange, and I'm the first one to admit it. The diverging ones always seem to throw people off a bit. It doesn't matter where I put it, so I'm going to go ahead and put it outside the focal point, but this is completely immaterial because it doesn't change what happens. Walk me through what happens. I've got a parallel ray of light coming here. Now what? It's called what kind of a lens? Diverging. So I need to diverge away, which tells me I need to come from this focal point, not to this focal point. So it's going to come from here. That's really important. It comes in parallel and then leaves as though it had come from this focal point. It's a virtual focal point, so to speak. I mean, it's a virtual image that's going to form, so that's what's going to happen. All right, what's the next ray I draw? Aim for this focal point. We've already involved this, so aim for that focal point. And then what happens? Instead of going there, it diverges and comes out horizontal. If I came in horizontal, I would bend away from this focal point. I come horizontal, I bend away from that focal point. So just the reverse. Aim for the other focal point and come out horizontal. What's the last ray? through the middle, and we breathe a sigh of relief for that. All right. So if my eye is on this side, I'm seeing these rays diverge as though they were coming from, all right, and that's just weird, but that just happened to work out that way, but okay. So there's my image. Breaking a lot of chalk today. I'm trying to be really emphatic. All right, so this is object and image. Do you see how I got the image? I got these three rays. I traced this one back, I traced this one back, and I traced this one back. And where those three cross is where the image forms. Oh, yeah.
Can you explain the first shape, please?
Sure. I come in parallel, and then I come away from the focal point.
Okay,
And then I aim for the focal point and come out parallel. The way to test that is, if I had come parallel this way, I would come away from this focal point.
okay, so it'd be the same thing if we were going to the focal.
In other words, what it is, I do it from this side, then it's like I do it from this side, because light has to be able to do the same going in either direction.
Okay, yeah, that makes sense.
Yeah.
So this is a virtual,
How do you know that it's a virtual image? No further ado.
it's coming back instead of going on the other side.
That's a good answer, but there's an easier one. It's right side up. The image is right side up, therefore it's virtual. If I have a single lens or a single mirror and the image is right side up, it is virtual. But you're also right, is that light went to this side but appeared to make an image on this side without ever going back there. So it's a virtual image for that reason as well. Good.
Why do lenses have two focal points?
Why do they have two focal points? Because light can come from this side or it can come from this side. So we have two focal points from which it can diverge depending which way the light goes. Mirrors can only have one because you can't go through the mirror. But on a lens, because a transparent light can come from either side, so the focal point is determined by where it diverges from or converges to. So if I come parallel on this side, on a diverging lens, it'll diverge from this focal point. But if I come on this side, it'll diverge from this focal point. So I have to have two, because light can go either direction.
So we can also reflect?
Lenses can reflect, but that's not what we're talking about. We saw the reflection in the lab. What I'm saying is, if I've got a diverging lens, if light comes in like this, it diverges from a focal point on that side, so there's a focal point here. But if light came this way, it would diverge from a focal point on this side, because it's still a lens. So there's going to be two focal points depending on which way the light goes. But those two focal points can be drawn in the same image. Guys, I've got to excuse you because it's two. I'll stay and answer questions, but people who need to go, it is two, and you're excused. So,
For F, you said it's diverging lens and it's, you put convex, isn't it concave?
I said it's a diverging lens, and it is concave. I may have misspoke, but I don't want to own that. I never make mistakes.
So it is concave.
It is concave and diverging. Is that, so I did say it wrong?
On the, yeah, you put convex for.
I put, yeah, totally wrong. Concave and diverging. Sorry. Yeah.
So going back to the sign of the focal length, in this case, for this diverging lens.
Because the focal point is never on the side light goes, it's negative. And because the focal point is on the side where light goes, it's positive.
Okay, got it.
So converging always is positive, diverging is always negative focal point.
Yeah.
Always for any situation. All right, so guys, on Friday, take a look at this list and make sure that you shoot your eyesight where you have the biggest problems, and we'll see if you try to get as much of that covered on Friday as you can. No? Come on now. Squatter's rights. So this is my output. So I come in and I converge to the focal point. I come from the focal point and I can parallel, because and parallel would go towards the focal point. Right? Parallel light always goes to the focal point. Right? So this one would do this, but it's going the other way. So I can convert it.
Oh, yeah.
It goes out away from the focal point.
But why is it outside? Is there one
Don't make it go both directions. We can't make it. Almost like that stuff from that side makes them just here and stuff this side. That's not. Alright, so don't do both at once. So what is it? So we're on- Yes, obviously, we're not gonna do both, we're not gonna do both at the same time.